All right, guys, all I've done was write and reload my devices. Now, the reason I did this is I wanted you to understand that quite literally you can chase the rabbit down a hole and you can get stuck. There are going to be instances in the lab where the best course of action is going to be reload. And I know that's going to terrify some of you guys, but it's definitely worth doing the reload, especially in a virtualized environment, because the devices are going to come up extremely quick. It's not like you're waiting for the actual hardware to mount and the software to actually expand and decompress the iOS. You're going to be up lickety-split in a virtual environment. And you should not, as a well-trained CCIE, be afraid of rebooting your devices. However, when you do reboot your devices, you're going to want to make certain that everything that you did up to that point returned and became operational. So you're going to check your routing protocols, you're going to check any of your base configurations, redistribution, and things along those lines. Also keep in mind, if you have something like RIP in your environment, you're going to want to give it time to basically percolate to where everything's going to return and everything's going to be fully converged before you go insane and start doing a lot of testing. So let's verify the fact that the reload worked. So all I'm going to do is on the hub is I'm going to type show DMVPN, and now we see we have our information. I'll just go ahead and type detail. And now remember, we removed all that crypto stuff because all I wanted to try to do is determine whether or not it was causing us a problem. But the thing is if in the lab, if you remove it to see if you did something wrong, you got to put it back. And if you put it back and you put it back wrong, guess what? A single FATFICR mistake can cost you an entire section of your lab. So these are all things that we want to make certain that we effort to avoid. Now, how do I know it's working? Well, let's go to our spokes. And even though we're getting these errors, I got to figure that out. We still should be able to ping 10, 10, 10, 2, 10, 10, 4. That's me. 5 and 6. All right, now let's put these commands back in that we had. The main idea here is that we wanted to reinstate the tunnels that we took out. So I'm looking to see if I can just grab them again without having to rewrite them. And I don't think I'm going to be able to. All right, we'll do it the hard way. So first of all, config T, interface tunnel 0, shut down that interface. I'm going to go to R4, interface tunnel 0, shut. I'm going to go to R5, EN, config T, interface tunnel 0, shut. Now what we'll do is we'll reapply those policies on the hub. Those policies, if I remember correctly, were spoke 1, spoke 2. So let's do this. So we did NHRP map group. The group that we said was going to be spoke 1. Service policy, output. And we did parent. Don't want to make a mistake again. Just bear with me. Do show run policy dash map. So parent spoke 1. So NHRP map group spoke 1 output, no, service policy output, parent spoke 1. Then what we want to do is we want to do this for spoke 2. Okay, let's go to R4, do show run, interface tunnel 0, interface tunnel 0. And what we want to do right now is type NHRP group spoke 1, go to 5, put it in spoke 2. NHRP map group spoke 2. Now what am I doing wrong? Oh, mapping. Duh. Spoke to. All right. No shut. No shut. No shut. Show DMVPN. Show DMVPN detail. And now we see what we want to see. So, why did I do this? To drive home that the order of operations matter. Before you start futzing with these interfaces, make certain that you turn them down so that when you're doing it, if you're doing it like I did it on the hub, and then I talked and I talked and I went to the spoke and I did it on the spoke, and then I did it on the other spoke. What you need to recognize here is the timers all failed on the hub well before I could get the configuration up and make it operational. Now, the easiest way to do this is to not break your network in the first place. The moment we set it up on the hub, we broke communication and everything is going to be hanging. So now what we need to recognize is by turning the interfaces off and then going to the individual interfaces and bringing them back up on a case-by-case basis so that we can do it very quickly is going to be the easiest and fastest way to make this work. Also, bring the spokes up first. Because remember, they're receiving the information from the hub. So if I set the hub up first and get distracted or something goes wrong, I can still time out. So bring the spokes up. The spokes are going to wait to receive the information from the next hop server with regard to the QoS configuration, and everything will be hunky-dory and fine. All right? So let's look at this a little bit closer before we wrap up this portion of our conversation. Now, like I said, remember I have my detailed configs. So inside the confines of my detailed configurations, I have parent spoke 1. I have all of my configurations operational. Let's come down here. And then the other part of this is let's do this. Let's say show policy map. And what I want to do is I'm going to say show policy map. Instead of interface, I'm going to say multipoint. So if I say multipoint and I hit enter, notice it's telling me everything that I want to know. So what I'm going to do is I'm going to blow this up so we can look at as much of it at one time on the screen as possible. And I'll move this to a new screen. There we go. So actually I went a little bit too high. All right, there we go. So let's look at our QoS policy that we have running here. Notice it's spoke by spoke. So from the tunnel interface to 4, we're running a service policy output that is going to be parent spoke. Inside the class default, what we're doing is we're queuing. And what we're doing is we're going to queue limit up to 386 packets at a single time. We are going to be shaping. Here's how we're actually shaping, because here is our rate. 2 million. So the CIR is 2 million. In order to be able to do that, we're going to send 8,000 packets at a time, or 8,000 bytes at a time. So as we go through and start looking at this, this is going to be our parent, but also inside there recognize that we have a service policy child where we're saying that anything that matches ICMP is going to actually receive a priority of 512 kilobits, which means my burst size is going to be up to 12,800 bytes per second. So again, we can look at this and realize that we still have a default class here. And then the other component here is going to be tunnel face interface 0 connecting to 183.1.355. Now the idea is that this is the NBMA address, the non-broadcast multi-access address. So again, when we start looking at this, the idea is to recognize the simple fact that everything comes together, and now what we have is a true hierarchical quality of service mechanism, where we have our class default, where we're actually doing the shape. This time we're doing it to 1 meg, like we said, for spoke 2. Inside of this quality of service mechanism that we've done with regard to the shaping queue, any traffic that satisfies the criteria of ICMP based on using NBAR is going to receive a priority treatment of 256 kilobits. So in other words, up to 1 meg that I'm shaping, up to 256 kilobits per second are going to be devoted to any ICMP traffic. Now, is this realistic? No, it's not realistic, but I can generate pings to do tests and do verifications where it's very difficult for me to actually create VoIP traffic unless I want to use something like a high-end IPSLA configuration. All right? So with this being said, we've addressed everything. I've shown you all of the dangers. Let's see, tunnel interfaces look like they have a different default queue limit. Let's take a look at that. Let's see. Well, I mean, they're going to, but let's look at why. Chief noticed that when we look at our configuration here, we have a queue depth difference. The queue limit here is 250 packets. Let's scroll down to the other. So that's going to be from 1 to 5. Let's look at 1 to 4. Here it's 360 packets. Well, Chief, in order to be able to facilitate shaping to 2 meg, I need to be able to hold more packets in my queue, right, than I would if I was down here shaping to 1 meg, which means I don't have to have as many packets in my queue depth. So the main objective here is I'm sending more information. The more information I send, obviously, the more I want to be able to cache or to queue, log up with regard to my queue. So here my queue limit is 250 packets. Up here in my parent policy, my queue limit is 360 packets. But the reason being is here I'm shaping to 2 million. Down here, I'm shaping to 1 million. So it's not like a half ratio, but the idea is that the more information I'm going to send, obviously, I have to recognize the fact that I'm going to be receiving bytes of information at a higher rate because I'm going to be shaping at a higher rate. So I want to be able to cache more when I'm going to be sending packets out. Does that make sense to you? Yes, it's a dynamic adjustment made by the policy. No problem at all. All right. So the last element to this is going to be the final verification. And now what I want to do is I want to look at the group name information. So on the hub, show group or show IP in HRP. And what I want to see is my group maps. And now I can actually see them. So I've got transport endpoints using this QoS policy is this endpoint. Spoke to this endpoint. Another command that I really think is important is for us to be able to take a look at, I'm trying to remember the syntax, just bear with me one moment. Was it the detail command? No. I already showed you the multipoint command. That was what I was thinking of, multipoint. This configuration right here. This is the equivalent of the show policy map interface for our DMVPN configuration. All right. So with that said, I'm going to wrap this portion of our video, and that puts all of our basic and intermediate topics for DMVPN to bed. So when we come back, what we're going to do is we're going to start focusing on some other topics, and I'll see you guys in those videos. So bye-bye.